Okay, so this is the shawl, and it's made out of these Adafruit, like, I forget what they're called, neopixel gemma thingies. Let's see, I think I might have it right here. Well, in any case, I found a vendor on Alibaba Express that will sell 100 of them for the price of like 20 from Adafruit. So if you want to go this route, let me know and I can look up that vendor's name. Oh yeah, these are called Flora NeoPixels 2. And I just wanted to say, I owe you like huge for pointing out these Wagyu connectors. These things are the freaking shit, man. It makes some prototyping just like so much faster. So let's see if this works off the bat. It's been a while. Cool, so what we got going on over here is, this is that proto board system I was telling you about before. Not sure if the rotary is working. Okay, there we go. Okay, so we got that. We've got power running into this strip I've made. And Lisa's already sewn the first one into the scarf, but I have a couple other ones sort of handy. So this is what I've been making. These are the Flora neopixels. And they're designed to be sewable, so you can get conductive steel thread and sew them directly into cloth. And the way you do that is you sew them onto the top surface or onto the bottom surface with a little hole cut out for them, and then ideally lay down more cloth to cover their back so that any steel circuit traces that are sewn into the cloth are covered by another layer of cloth. But we're working with this really thin, like gossamer shawl. And so ultimately for safety and for strength, I decided, and for speed, it turned out to be faster just to like manufacture these strips from precisely cut lengths of silicone tubing. So anywho, we've got this breadboard jankified thing, and all we gotta do is plug in the data line. Oh, by the way, this is the cool thing about the silicone. You can just strip it with your thumbnails if it's thin enough. And if you've got Wagyus, then man, you're really going. All right. So cross your fingers. Let's see if this works. Sweet. Rad. So rad. So it's kind of hard to get a sense of the full effect here, but let's see if I can kind of stretch some of this stuff out. Maybe I'll put this stuff on the other side. Cool. So yeah, the strip is basically working. And now if we hit the right. Cool. Yeah, so it works. It's extremely bright too. It's actually like brighter than the strips. I think, I don't know why, but yeah, so it's pretty rad. This should just give you a sense of like how maybe to do. This is sort of like the ultimate in flexibility, right? And then if you want to see the back, Lisa's been sewing them in. She's basically just doing like a crisscross around every 3 or 4 of these. And then we've got this like cloth bookbinding tape stuff, or like fabric tape. And I think for like more or less that'll work. We could also try sewing through it to make it stronger. So yeah, that's how that works. And I think for you, what I would do is I would probably try just working with the strip. I'm not sure, but like it sounds like for the marching band uniform, you could do sort of like 12, 10, 8, 6, 4, whatever. Make these like these sections that move down or whatever you're thinking. But it takes fucking forever to solder these chains, these like DIY strips. It's basically like 10 minutes per piece or 5. And this scarf calls for like 70. So very happy to tell you more about how specifically to work with these Gemma dot stars if you want. But if you don't want, if you want to just use the strip and figure out a way to connect them, I can tell you about that too. And I would say that the most like kind of tricky thing is figuring out how to route power if you have long strips. Like 1 meter to 2 meters of total strip length is enough, is not too long to, or rather I should say it this way, 72 LEDs needs power input only on one end of the strip. And it might be more effective to run, if you're doing the power input, so there's the whole strip. In this case, the data and the power is coming in at this end, but you can effectively insert the power on positive and negative traces by soldering in anywhere along the length, and those two traces act like a rail that powers each LED. The data line always has to go at the very like the start end where the arrows point away from, but the power can go in anywhere. And if you have a really long strip, then you inject power again every like 72 LEDs. So I think that for your case, you could just run thick cable down one side of the like lapel or wherever, and then for each row of strip, just kind of stretch out some smaller wires and connect them to the strip's power. And then like serpentine connect the data line. One last thing, I'll show you how we're doing it with the scarf here, or I mean the shawl. Cool. Okay, so there's the shawl. It's a triangle, and this is the start of the chain. So here's the data line. No power though. Instead, in the center of the shawl, there are these 2 taps for power to be input to the whole row. And basically we're gonna run 2 thick power lines down the midline of the scarf, and those will connect the midpoint of each strip. So it should be pretty good at distributing like enough power. This is basically the plan. Those cross-off lines are ones that I've made. And then there's the dotted line is the line that the power will run down. So yeah, there you go. Call me back if you have any questions. I hope this wasn't too long and boring. Good luck, man.